Okay, so you can see that I added the dynamic pressure to our list of equations that we now know, and now we want to put it all together. So just as when we talked about mechanical systems, we said that any object is going to have both kinetic energy and potential energy, we're going to say that a fluid is going to have both static pressure and dynamic pressure. So that in this picture here that I've got, you have a pipe that begins at a certain height off the ground, and then it ends at a different height. Another thing that you notice is the areas, so that the fluid goes into the pipe with a certain area, and then it comes out of the pipe at a different area. And then a third factor is going to be the speed of the fluid. So the speed of the fluid going in is going to be different than the speed of the fluid coming out of it. And then you got the pressure going into the pipe is different than the pressure coming out. So when you put that all together, you get this kind of complicated formula there. So that the initial pressure going into the pipe plus the static pressure in the pipe, going into the pipe, plus the dynamic pressure going into the pipe is going to be equal to the pressure coming out of the pipe, the static pressure coming out of the pipe, and then the dynamic pressure coming out of the pipe. So here is a sample question. Now, if I was teaching this course, I would not give you this question on an exam. But since we've got time to be able to do it in depth, there it is. So given are the parameters for a fluid of density 1500 kilograms per cubic meter. So notice this particular fluid, whatever it is not water. So I'm giving you the speed of the fluid going in. You need to figure out what is the speed of the fluid coming out. I give you the area of the pipe going in and the area of the pipe coming out. I give you the height of the pipe going in, and then the height of the pipe coming out, and then I give you the pressure going into the pipe, and your goal is to figure out what is the pressure coming out of the pipe. So let's start by figuring out what is the speed of the fluid coming out of the pipe. And so in order to do that, we're going to use conservation of volume flow rate, so that the speed going into the pipe times the area going into the pipe has to equal the speed coming out, and then the area coming out of the pipe. So we know what the speed going in was, we know the area going in, and so we're going to solve for the speed coming out, and it turns out to be 15 meters per second. Okay, next we're going to calculate the following terms. So the first one there is the static pressure going into the pipe. But notice that the height is 0, so 0 times anything is going to be 0. Okay, then we calculate the dynamic pressure going into the pipe by knowing the density of the fluid and the velocity going into the pipe. Okay, and then we calculate the static pressure coming out of the pipe, and then we also calculate the dynamic pressure coming out of the pipe. Okay, now we're going to take all of that information and we're going to put it into our equation for the total pressure acting on the system. And then we solve it for the pressure coming out, and it turns out to be 912,000 pascals. All right, let's take a break. When we come back, we will talk about fluid resistance.